Good morning, dear students. Hope you all are good. Have you understood what was taught yesterday? I hope it was clear to you. So let's start with our next topic of second chapter. Is matter around us pure? As told yesterday to you that we are going to start with suspension and colloid. These are the two topics to be covered today. First of all, try to understand what is suspension. A suspension is a second kind of a mixture we are going to talk about. If you remember, yesterday we did the first kind of mixture, that was true solution. Now we'll be talking about suspension. It's a heterogeneous mixture in which the solute particles do not get dissolved but remain suspended throughout the bulk of the medium. For example, chalk in water, smoke in the air, etc. Try to understand here. So, this is the example of a heterogeneous mixture. If you remember, heterogeneous means composition is not same throughout. And here we have talked about an example of chalk and water. Children, you take a beaker, put water into it and put some chalk powder into it. Stir it. Try to dissolve. You will see chalk is not going to get dissolved into the water. And after some time, you'll be able to see the separate boundaries in this beaker. Chalk powder will be settled at the bottom, and above it, it will be water. So there is a boundary distinguish. You are able to see the boundaries, and the composition is not same throughout. So such a kind of a mixture, we call it as suspension. Now, to talk about its properties, first of all, see the first itself, it's a heterogeneous mixture. Particles of a suspension are visible to the naked eye. This means they are big enough to be seen with the naked eye. And if we talk about the size of the particles of suspension, they are pretty big because we are able to see them with the naked eye, and they are more than 100 nanometer in the diameter. The next property says it is unstable mixture. If you remember, yesterday also I have explained you what is unstable and what is stable. If you keep this suspension for a while, maybe for 10 minutes or maybe more than that, or maybe just 5 minutes also, you will see the solute particles, that is the chalk powder put into the water, will settle at the bottom. So this is called as a unstable mixture. The next property says if you want to separate the chalk particles from the water with the process of filtration, you can easily do it with the help of the filter paper. And the next property says the Tyndall effect. Children, if you remember, yesterday also I explained Tyndall effect to you. It is the effect in which we say the particles of solute are big enough to scatter the beam of light falling on them. So here, as the particles of suspension are very, very big, they are easily able to scatter the beam of light. So we say suspension is the mixture which shows the Tyndall effect. Now children, let's talk about the another kind of a mixture, which is a colloidal solution. Another name for the colloidal solution is SOL, S-O-L. See here, don't get the confusion. SOL dot, you may see sometimes it is written as the short form of solution in chemistry. But here when you write SOL, SOL is SOL, and SOL means it's the colloidal solution we are talking about. It's not the solution. Colloidal solution, another name is SOL. Colloidal solution is a heterogeneous mixture in which the size of the particles lies between the true solution and suspension. Here, something very important, children. Just now we said it's a heterogeneous mixture, but practically I just want to give you the clarification here. When you will see the colloidal solution, they are actually the heterogeneous mixture, but they seem to be homogeneous from outside. They look like as if they are homogeneous, but basically they are heterogeneous mixture. And if we talk about the size of the particles of colloidal solution, they are neither too small like of the true solution particles, and nor they are big like the suspension particles. So they are in between. Their size is in between the true solution particles or the suspension particles. So now we will be discussing at last the properties of colloidal solution. The particles of colloid cannot be seen by naked eyes individually. It is a heterogeneous mixture, just now I have told you, but it seems to be homogeneous. And the solute and the solvent cannot be separated by filter paper here. Size of particles is smaller than suspension but greater than solutions. It is a stable mixture. Now you have something, you have understood that stable means if you are going to keep this colloidal solution for some time, you are not going to disturb it, then there won't be separate layers of the particles which are mixed into the solvent, and they do not settle down when left undisturbed, which means it is quite stable, we have just seen. And it is a stable mixture. Particles do not settle down at the bottom over a period of time even. Here the best example you can see, milk is the example of a colloidal solution. If you take milk in a glass or in a beaker, you will see it's a homogeneous mixture, ma'am. The composition is same throughout. But when we'll go into the details of the particle size and other properties, we'll see it's not a homogeneous mixture, rather it's a heterogeneous mixture. Now something very important related to colloids, children, try to understand here. Generally, in case of colloids, we don't use the terms solvent and solute. For solvent, we are using the term dispersing or dispersion medium here. And for solute, we'll be saying it is dispersed phase. You remember, the component in a smaller amount is solute and component in a larger amount is solvent. But here, in case of colloids, we won't be using the term solvent and solute. Rather, we'll be using dispersed phase and dispersion medium. This is the table given in your NCERT books also, and how to go about it, just try to understand. Definitely you will get the question in the exam from this table. You just have to learn the examples of different sols or the colloidal solutions, and you'll be talking about which is the type of the colloid and which is the dispersion medium and which is the dispersed phase here. See, the very first example is you have when the dispersed phase is liquid, medium is gas, then this type of colloidal solution is called as aerosol, and the example is fog, clouds, mist. So this way you have to go for. Suppose if the solid is the dispersed phase and the dispersion medium is again the gas, then again we are going to call it as aerosol. Example, smoke, automobile exhaust, etc. If the dispersed phase is gas and the medium is liquid, we call it as foam. For example, your shaving cream. Liquid into liquid, we call it as emulsion. For example, milk, face cream, etc. You must have heard about emulsions that we put on walls. That is liquid into liquid. When it is solid into liquid, we call it as sol. When gas into solid, we call it as foam. When liquid into solid, we call it as gel. And solid into solid, we call it as solid sol. For example, we have gemstones that we wear in our rings or in our jewelry. So these are the few examples of colloids. Children, please try to learn this table. Definitely it seems that it is difficult, but once you will go through it, you will be learning it easily. That's all about the today, and whatever is taught, please go through it. Today also there is no homework for you. Simply whatever I have explained, go through it again and again and try to understand. Tomorrow you will get the question answers to be done related to these two topics. All the best, dear students, and please do it carefully. All the best. Bye bye.